So here are some of the procedures for this lab as listed out in the posted Word doc. So open this particular Desmos link that I have supplied on Blackboard, and you find this, and the only thing that you really see here, I'm moving this around with the mouse, is the orange ball here, which is supposed to be the sun. Here I'm going to drag this out a little bit further. This is the equation for the ellipsis, but notice certain things are missing there, and that's what you have to fill in, and I'm going to show you how to do that. Go all the way down here. I'm going to close this for a moment. I don't need this. I'm going to open this, and you need this big symbol lab link, the entire thing. I'm going to copy that, post it into a new tab, and there we go. What you see on the very top, this one here is the equation of an ellipse in a plane. So just flat ellipse. These are the transformations for the inclination that puts it into three-dimensional space, for the longitude of the perihelion and for the longitude of the ascending node. And Symbolab has already computed this because I told it to. And you can do this too if you really want. You can try it. It's actually relatively straightforward, except you would have to type quite a bit here, right? And so it does all the algebra, and there you go, and it shows us the steps here and so on. And this is the solution. This would be the ellipse now in 3 dimensions with those orbital elements that I talked about in the other short video. And this is what you would have to compare in Desmos. I'm going to go back to Desmos in a moment. Unfortunately, Desmos doesn't list it as such a nice vector. Instead, it just goes on very long line and puts a comma right here, puts a comma right there. So look at this, b sine t minus cosine o sine w. Go over here, and let's see. b sine t minus cosine o sine, oh, the w is missing. There we go. And then you would look here and compare to Desmos right here and try to fill this all out. Again, here's one missing, so fill that one in. I'm just going to give the very last one away. There's a total of 5 mistakes here. 5 of them are missing. I'm going to fill in the very last one because it could be easily overlooked. It's right here. See, there's a plus with nothing there, so I'm going to go back. This would be on the last line then. And you see here's sine j, a in the front, sine w, cosine t plus h. And there it is, a sine j, sine w, cosine t plus h is missing. Okay, I'm going to pause this here for just a moment so I can fill in the others without not giving more away, because I want you to do that. Filling in. All right, I'm back. So I filled in the others, and here's the very first one. There we go. Down here, this is for animating the orbital motion of the planets. This one is for simply drawing the orbit, and you just saw that's what happened. So this one is for animating it, and there is the planet. This would be Mercury appearing, and if I click the forward button here, the play button, there we go, Mercury orbits. Okay. Now Mercury's orbit is the only one showing here. Jupiter's orbit is there as well, by the way. So you also have to fill in the orbital elements. I'm missing of them for the other planets. I don't need this web links anymore. I'm going to click on this one here. So again, maybe I said it already. So you have 5 mistakes in here that you have to fix, and you have the same 5 mistakes in here that you have to fix. Okay. So I just opened this one here, planets orbital elements. There we go. And notice the blanks in here. All right. So here, Mercury's orbit shows because it's all there, and I enabled the ellipse and the motion. So is actually Jupiter's. So if I go in here and I zoom out, there we go. There is actually Jupiter's orbit. And we could also see Jupiter orbiting at this point. It's going to do it really slow, of course, because it orbits much slower than Mercury because it's further out. All right, I'm going to fill in these here for the terrestrial planets. You also have to do the other planets then, starting with Saturn, Uranus, Neptune, and Pluto. And these missing orbital elements, they could be Googled, respectively. I'm just going to, I also put them in here in the sheet for the project. So we go. At least I tried to put it in there. Why didn't that work? Try this again. There we go. So here it is. Please stay there. Move this one over so we can see both at the same time here. So if you look, for example, for Mercury at 0.387, 0.39, 0.207 for the eccentricity, 0.2056. Well, if I use slightly different tables, very slightly different results, that's okay. And then inclination, 7 degrees, and so on. So for Venus, it would be the same thing. So what's missing for Venus would be a semi-major axis. So here's the 0.723. And now Venus orbit will appear. You already see it over here. Actually, it was Jupiter's orbit. So if I zoom further in, there we go. Venus orbit appeared. I'm going to get this a little bit over here. I'm going to copy Earth's down. So Earth's eccentricity is missing. So it's the 0.0934. And you saw Earth appearing over there. And Mars is, the inclination is missing of 1.85 degrees. And now Mars popped into view as well. All right, and then you would have to still fill in for the other planets that I didn't do. I'm going to do a little bit to show you. But there's one more step here, and that is this one here, the L, which is called the longitude of the epoch, and that would be kind of the starting point. So if I give you here this top view, for example, we can see, well, if I, which way I turn it. Actually, this was okay. There we go. If it stops turning on me. And then go back here to L, which has all zeros. And the L is between 0 and 360 degrees. For example, for Mercury, I could do 55. And notice Mercury shifted. You know, for Venus, I could do 199. And there it is, that kind of thing. All right, I'm going to put these back to 0. And I need to check them from another solar system simulator. And when I typed this one in, I found two that I like. One of them is the solar system scope. So here we go. And the other one is, this is also good, my solar system at PHET, but it doesn't show what I wanted to show right now. So here's the other one. 3D solar system, and I have a top view here. And I'm going to turn off these comments here. You can choose any day you want, so you can change this particular day here. I'm just going to play with this one here. There's apparently the day before Christmas Eve, actually, because it's universal time. It is actually Christmas Eve, what I have on here. And notice that I have Earth on the top, Mercury a little bit left from the top, Mercury also pretty much a little bit left from the top. So I'm going to go back in here. And for Earth, I'm going to just try some number between 0 and 360. Earth would be this one here. And I'm going to try, perhaps 180. Yeah, there we go. Because I knew it was here, and then it would end up there. There we go, that was good. And Mercury is, it's pretty close. So I'm going to do a 22. Whoops. 22. Oh, good, good. Otherwise, I would have tried negative 22. Or 338. I'm going to go back here. I'm going to look for Venus. Okay, Venus to the left and Mars at the bottom. Okay. So Venus on the left. This would be Venus here. So I'm going to try also, I'll try 33. Oh, very close. 30. That's good enough. And Mars at the bottom. So I'm going to try 222. Okay, way over there. I'm going to try 333. No. I am looking at Mars. Oh, okay, I'm going to try 111. There we go. Ooh, very close. There we go. There, right on, 120. So now this looks really similar to what I have here. By the way, this one here, really kind of similar. This is actually a little bit more fancy. I do like this better, but for this project here, maybe a little bit too much. In fact, I have to go through settings. Sure, welcome there. And let's see, realistic planet sizes. And I want to turn the audio off. Oh, it is off. That's good. Okay. All right. And then go in here. I have to probably have the same day here. Yeah, here. Well, this is actually my local time, so it's the evening before. I put Mercury on Earth on the top, and there it is. Just left of top Mercury, the same thing. Venus on the left, and Mars at the bottom here, right? And it's really similar to what we have here. Maybe if I turn this one a little bit. There we go. Right. So anyway, that's what you have to do, and you have to fill in these others. And yeah, you have to do this project by yourself. And then once it's done, and you can zoom out to Jupiter and Saturn. Saturn is not on here because I didn't do it. You would have to, and then you click the play button, and there's the working solar system. In this case, the inner 4 planets, but the others are there too. And that's this project.